Welcome to another deep dive. This time, we're going to be looking at large language models, or LLMs.
LLMs.
Yeah, you've probably seen them in action, writing stories, answering
Mm.
questions, even coding sometimes.
It's amazing what they can do.
Yeah, but behind these really impressive feats lies a challenge.
Mm.
How do we actually talk to these LLMs effectively? Like how do we get them to do what we want?
Right.
And it's all about crafting these really perfect instructions, and that's where prompt engineering comes in.
Yeah, and it's not as straightforward as it sounds, especially as these LLMs are being used to power more and more complex applications,
Okay.
like multi-hop retrieval systems, where the model has to figure out what information it needs,
Yeah,
find it, and then synthesize an answer.
right.
Getting those instructions right manually
Yeah.
can be a real bottleneck for developers.
Okay, I'm starting to see the issue. So it's not just ask a question and get an answer anymore.
No.
What makes prompt engineering so tricky?
It's like imagine you're trying to explain a task to someone who's incredibly smart,
Okay.
but has zero context.
Mm-hmm.
You need to be incredibly precise
Right.
and account for every possible misinterpretation.
Yeah,
But with LLMs, it's even more challenging because they don't think like humans do.
right.
So you end up with these developers spending countless hours tweaking these prompts, running tests,
Wow.
and basically playing this never-ending game of guess what the LLM wants.
That sounds incredibly tedious. But what if there was a way to automate this? To
Yeah,
have the AI learn to craft its own prompts?
that's precisely what this paper is automating. Auto-differentiating any LLM workflow. A farewell to manual prompting explores.
Okay.
They've developed this framework called LLM-AutoDiff that promises to do just that.
A farewell to manual prompting?
Yeah.
I like the sound of that. But how does it actually work? Is this just a clever algorithm?
Hmm.
Or is there something more fundamental going on here?
It's a pretty radical shift in thinking. It draws inspiration from automatic differentiation, which is this concept that revolutionized deep learning.
Hmm.
In deep learning, you have these numerical parameters that are adjusted to optimize the model.
Yeah.
Well, LLM-AutoDiff does something very similar, but with text.
Hold on.
Yeah.
That sounds mind-bending.
Huh.
How do you apply the concept of differentiation to text? It's not like we're dealing with equations here.
Right, but think of it this way.
Yeah.
Every textual input, every prompt, can be seen as a parameter that influences the LLM's output.
Hmm.
LLM-AutoDiff represents the entire LLM workflow as a directed graph.
Okay.
So kind of flow chart.
Yeah.
Each element of the workflow, whether it's an LLM or a data retrieval module
Right.
or even a simple operation, is a node in this graph.
Okay.
And the prompts,
Yeah.
they become the adjustable knobs within this system.
I'm starting to get the picture.
Mhm.
So instead of us manually tweaking these knobs,
Yeah.
LM-AutoDiff figures out how to adjust them automatically.
Automatically.
That's slick.
Yeah.
But how does it actually know which way to turn those knobs?
That's where the concept of textual gradients comes into play.
Okay.
It's analogous to numerical gradients in deep learning.
Right.
But instead of adjusting numbers, we're adjusting text.
Okay.
The system figures out how changes to a prompt ripple through the entire workflow and affect that final output.
Hmm.
And then it uses this information to generate feedback in the form of textual suggestions.
So it's like the LLM is getting feedback on its own instructions. But this feedback is given in the form of text, not like grades or scores.
Exactly. It's like having an AI writing coach
Right.
that says, hey, if you phrase your request this way, you'll get a much better response.
Hmm.
And this feedback is then used to automatically refine the prompts,
Okay.
making the entire system more effective.
This is starting to sound really powerful, but can we walk through a concrete example? You mentioned multi-hop retrieval systems before.
Yeah.
How would LLM-AutoDiff actually improve a system like that?
Let's say the task is to answer a question
Okay.
that requires pulling information from multiple sources. The system might first need to generate a search query,
Yeah.
then retrieve relevant documents,
Okay.
summarize those documents,
Gotcha.
and finally synthesize a concise answer.
Right.
Each of these steps would be a node in that LLM-AutoDiff graph.
Okay, so we have our workflow laid out. Where does the optimization magic happen?
Well, initially, the developer would provide some basic prompts for each step.
Okay.
For example, for that query generation step, the prompt might be something like,
Okay.
given the following question, construct a search query to retrieve relevant documents.
Okay.
LLM-AutoDiff would then take over,
Right.
analyzing how well those initial prompts are working and using textual gradients to suggest improvements.
Hmm.
Maybe it figures out that adding an example to the query generation prompt significantly improves the accuracy of the retrieved documents.
So it's not about replacing the developer,
Right.
but giving them a powerful tool to refine their prompts and find those subtle tweaks that can make a huge difference in performance.
Precisely. And this applies to every single node in the workflow.
Right.
Maybe it discovers that the prompt for summarizing documents is too vague,
Okay.
leading to summaries that miss crucial details.
Gotcha.
LLM-AutoDiff could then suggest adding more specific instructions like
Okay.
focus on extracting key facts and figures related to the original question.
This is starting to feel like a total game changer for anyone working with LLMs.
For sure.
Instead of manually fiddling with prompts,
Yeah.
you have this AI assistant working tirelessly behind the scenes
Yeah.
to optimize the entire workflow. But what about those parts of the system that don't directly involve prompts?
Right.
How does LLM-AutoDiff handle that?
That's another clever innovation they introduced. They call it pass-through gradients.
Okay.
Essentially, even components that don't have prompts can be influenced by that feedback loop. Imagine a module that filters retrieved documents based on their relevance.
Yeah.
LLM-AutoDiff can still analyze how that filtering process impacts the final answer, and then use that information to suggest changes to the prompts that control the retrieval process itself.
So even the parts of the system that don't speak the language of prompts
All right.
are still part of the conversation.
Exactly.
This is really starting to feel like a holistic approach to LLM optimization.
That's a great way to put it.
Yeah.
It's about looking at the entire system, understanding how all the pieces fit together,
Right.
and then using that knowledge to fine-tune every aspect of the workflow. And the potential benefits are huge. Faster development cycles, higher accuracy, and potentially even new applications that were previously out of reach because of the challenges of manual prompt engineering.
Wow.
Yeah.
Okay.
It's pretty cool.
Yeah, this is really exciting stuff. I'm really looking forward to seeing where this goes.
Yeah, me too.
All right, well, let's take a quick break, and when we come back, we'll delve even deeper into the inner workings of LLM-AutoDiff and explore how this textual gradient magic actually works.
Sounds good. Welcome back to our deep dive into LLM-AutoDiff. In part 1, we explored how this framework is revolutionizing prompt engineering, moving us away from tedious, manual tweaks and towards a world where AI can help optimize its own instructions.
Yeah, it's definitely a mind-bending concept, but I'm curious, how does this textual gradient magic actually work under the hood? It still feels a bit like alchemy to me.
It's a fair point. While the idea of differentiating text might sound strange, it's built on principles that are quite similar to those used in traditional deep learning. Let's break it down. Remember how we talked about representing the LLM workflow as a directed graph?
Yeah, that flowchart-like structure where each box is a component and the arrows show the flow of information.
Right. Now imagine you have a task like answering a question based on some text. We can measure how well the system is performing by using a loss function.
Okay.
This function tells us how far off the system's answer is from the correct answer.
Right.
The goal is to minimize this loss, which means getting closer and closer to the perfect answer.
So the lower the loss, the better the system is doing. But how do those textual gradients help us get to that lower loss?
Think of it like this. You make a small change to a prompt, like adding a word or rephrasing a sentence.
Okay.
That change ripples through the entire workflow, ultimately affecting the final answer and therefore the loss.
Okay.
Textual gradients capture how much that tiny change in the prompt influence the loss. It's like a sensitivity analysis for language.
Okay, so we're measuring how sensitive the system is to changes in the prompts, but we still need to figure out what changes to actually... That's where the optimizer comes in, right?
Exactly. The optimizer is another LLM.
Okay.
But instead of generating text like a chatbot, it's generating revised prompts.
Interesting.
It takes the feedback from the textual gradients, considers the current prompt, and proposes modifications aimed at lowering the loss.
So we have this feedback loop. The system generates an answer. The loss function tells us how good that answer is, textual gradients, pinpoint, which prompts need adjusting, and the optimizer proposes new prompts based on that feedback. It's quite an intricate dance.
It is, and the researchers have incorporated some clever techniques to make this whole process more efficient.
Okay, like what?
For instance, instead of calculating gradients for every single training example, they use selective gradient computation. This means they focus on the examples where the system is struggling the most, prioritizing those prompts for optimization.
That's smart. It's like focusing your study efforts on the subjects you're weakest in. But even with that optimization, I imagine evaluating all those proposed prompts can still be a time-consuming process.
You're right, and that's why they implemented a two-stage validation process.
Okay.
Instead of testing every new prompt on the entire dataset, they first do a quick check on a smaller subset. Only if the prompt shows significant improvement on this subset does it move on to the full evaluation. This helps to quickly filter out ineffective prompts and saves a lot of computational effort.
It's like a quality control check, ensuring that only the most promising candidates make it to the final round. Okay, so we've got this efficient system for generating and evaluating new prompts, but what about the optimizer itself? What makes this particular optimizer so special?
Well, one of the key features is its ability to learn from experience.
Hmm,
It keeps a record of past prompt revisions, noting which ones led to improvements and which ones didn't.
okay.
This proposal history allows the optimizer to avoid repeating mistakes and to favor strategies that have proven successful in the past.
It's like the optimizer is building up its own intuition about what works and what doesn't. But we're not just dealing with individual prompts here, right? We're talking about complex workflows with multiple components, each with its own set of instructions.
Absolutely. And the optimizer is designed to be system aware. It understands how the prompts for each component interact and influence the overall performance. This means it can propose revisions that are not only effective in isolation, but also beneficial for the entire system.
So it's like having a conductor who understands how each instrument contributes to the overall harmony of the orchestra. But with so many moving parts, isn't there a risk of things getting out of sync? What if a change that improves one part of the workflow ends up messing up another part?
That's a valid concern, and it's something the researchers have taken steps to address. The optimizer is designed to be peer aware,
Okay.
meaning it understands that prompts often have a modular structure. For example, a prompt might have separate sections for instructions, examples, and desired output format. The optimizer can edit these subprompts independently, reducing the risk of unintended consequences.
So it's like having a team of specialized editors, each focusing on a specific aspect of the prompt, ensuring that changes in one area don't create problems elsewhere. But with all these safeguards and optimizations, how accessible is LLM-AutoDiff to developers? Is this a tool for PhDs in AI, or can mere mortals like myself wrap our heads around it?
That's actually one of the most impressive things about this research.
Okay.
They've implemented LLM-AutoDiff within a library called AdalFlow, which is designed to be relatively user-friendly, even for developers who might not be experts in deep learning.
So no need to spend years studying advanced calculus and linear algebra just to use this tool.
Right.
That's a relief. But I'm still curious, what does the workflow actually look like? If I were a developer building an application with LLM AutoDiff, what steps would I need to take?
Let's imagine you're building that multi-hop retrieval system we talked about earlier.
Okay.
The first step would be to define your workflow in AdalFlow.
Okay.
You'd specify the different components like the LLMs, the retrievers, any data processing modules, and how they're all connected. It's like drawing that flow chart we discussed, but you're doing it in code.
So it's about mapping out the steps involved in solving the problem. What happens next?
Then you provide some initial prompts for each LLM component.
Okay.
These don't have to be perfect, they're just a starting point.
Hmm?
LLM AutoDiff will take it from there.
Okay.
You also need to provide the training data, in this case, a set of questions and their corresponding answers. This is what the system will use to learn and optimize the prompts.
It's like giving the system a rough draft of the instructions and a set of practice problems. And then LLM AutoDiff takes over, refining those instructions based on how well the system is performing on the practice problems.
Exactly. It's an iterative process. The system generates answers, calculates the loss, identifies areas for improvement, and proposes revised prompts.
Yeah.
This cycle continues until the loss is minimized, indicating that the system has achieved a high level of accuracy on the task.
That's pretty impressive. It's like having an AI assistant constantly tweaking and refining the system behind the scenes, striving for optimal performance. But I imagine even with this level of automation, there are still some limitations. What are some of the challenges the researchers are still working on?
One challenge is computational cost.
Okay.
While LLM AutoDiff is significantly more efficient than manual prompt engineering, it still requires substantial computational resources,
Right.
especially for complex workflows involving large LLMs and massive data sets. As we push towards even more sophisticated AI systems, finding ways to further optimize the efficiency of this process will be crucial.
That makes sense. It's like trying to run a complex simulation on an old computer. You need the hardware to keep up with the demands of the software. But what about limitations inherent to the approach itself? Are there things that LLM AutoDiff simply can't do?
One potential limitation is that the effectiveness of the system depends heavily on the quality of the backward engine and the optimizer LLM. These are the components that generate the textual gradients and propose the revised prompts. If they aren't well trained or lack the necessary understanding of the task at hand, the entire system might struggle.
So it's like having a brilliant strategy but lacking the skilled players to execute it. The underlying AI models still play a crucial role, but I also imagine that the complexity of the workflows themselves presents a challenge. As we build more intricate LLM-powered systems, is LLM-AutoDiff capable of keeping up?
That's another area of active research. The current implementation of LLM-AutoDiff focuses on static workflows, where the structure of the graph is fixed. But many real-world applications require dynamic workflows where the components and connections might change over time based on the situation.
It's like having a map that can't adapt to a changing landscape. How are researchers approaching this challenge?
One promising direction is to explore dynamically reconfigurable graphs. Imagine a system that can not only optimize the prompts, but also adapt the structure of the workflow itself, adding or removing components, changing connections, and essentially rewiring itself on the fly to meet the demands of the task.
That sounds incredibly complex. It's like giving the AI the ability to redraw its own map as it explores new territory. But if they can pull it off, the possibilities seem endless.
Exactly.
Hmm.
And another exciting avenue is to explore the integration of LLM AutoDiff with other optimization techniques.
Okay.
What if we could not only optimize the prompts, but also automatically tune the hyperparameters that control the LLMs,
Right.
or even fine-tune the model weights themselves?
Now you're talking. It's like moving from optimizing individual components to optimizing the entire machine.
Mm.
But wouldn't that require a level of complexity that's almost unimaginable?
It would be a formidable challenge, but the potential rewards are immense. Imagine a system that can truly optimize itself end-to-end, achieving levels of performance and efficiency that are currently beyond our grasp. It's a goal that's worth striving for.
It's like a glimpse into the future of AI, a future where systems can not only perform incredible feats, but also constantly learn and improve themselves, pushing the boundaries of what's possible.
And speaking of the future, in part 3 of our deep dive, we'll shift our focus from the technical intricacies of LM AutoDiff to its broader implications.
Okay.
We'll explore how this technology could revolutionize fields like scientific research, personalized education, and even creative industries.
That sounds fascinating. I can't wait to see what the future holds for this technology and how it might shape the world around us. Welcome back. We've spent the last 2 parts really digging into LLM AutoDiff, this framework that's essentially giving LLMs the ability to optimize their own instructions. Pretty wild stuff.
It is, and with any powerful new technology, we got to consider not just the how,
Right.
but the so what.
Exactly. What are the potential implications of this technology? How might it shape the world around us?
Yeah.
Okay, let's put on our futurist hats and explore some possibilities. We briefly touched on a few areas in the previous parts, but where do you see LM AutoDiff making the biggest impact?
One area that immediately springs to mind is scientific research.
Yeah, okay.
Imagine a world where scientists have these AI assistants that can not only analyze vast data sets, but also help generate hypotheses, design experiments,
Wow.
and even interpret the results.
That's pretty radical. It's like giving every scientist a team of superpowered research assistants working around the clock
Yeah.
to accelerate discovery.
It's not just about speed, though.
Right.
It's about pushing the boundaries of what's possible.
Okay.
LM-AutoDiff could enable researchers to tackle problems that were previously considered too complex or time-consuming.
Like what?
Like imagine using AI to design personalized cancer treatments based on a patient's unique genetic makeup,
Wow.
or developing new materials with very specific properties by simulating the interactions of atoms at a molecular level.
Those are some pretty mind-blowing possibilities.
Yeah.
It sounds like LLM AutoDiff could really unlock these whole new avenues of scientific inquiry, leading to breakthroughs we can barely even imagine right now.
Absolutely, and I think this highlights a crucial point. LM-AutoDiff isn't just about making existing processes more efficient.
Okay.
It's about fundamentally changing how we approach complex problems.
So it's not just about automation.
Right.
It's about augmentation.
Exactly.
It's about giving humans these powerful new tools to extend their capabilities and tackle challenges that were previously out of reach.
Exactly. And this idea of augmentation extends beyond just science.
Okay.
Think about education, for example.
Yeah.
What if we could create these truly personalized learning experiences, tailored to each student's unique needs and learning style?
That sounds like a dream come true for both students and educators.
Yeah.
No more one-size-fits-all classrooms where some students are bored and others are struggling to keep up.
Exactly. Imagine AI-powered tutors that can adapt their teaching methods on the fly, providing extra support where needed, challenging students when they're ready,
Yeah.
and even suggesting different learning resources based
Wow.
on the student's interests and goals.
That's a far cry from the static educational software we have today.
Yeah,
It sounds like these AI tutors would be more like mentors, guiding students along their individual learning journeys.
that's the vision.
Hmm.
And LLM AutoDiff could play a key role in making this vision a reality.
Okay.
Remember, it's all about optimizing complex workflows.
Right.
A personalized learning system is essentially a very sophisticated workflow involving components for content generation, assessment, feedback, and adaptation.
Mm.
LLM AutoDiff could be used to fine-tune the interactions between all of these components,
Right.
ensuring a seamless and truly personalized learning experience.
It's amazing to think that we might be on the cusp of a revolution in education where technology empowers us to learn more effectively and reach our full potential.
Yeah.
But let's not limit our exploration to science and education. What about the creative industries? How might LLM AutoDiff empower artists, musicians, writers, designers?
Ooh, this is where things get really interesting. Imagine AI tools that can help artists explore different creative styles, generate novel ideas, and even assist in the creation of entire works of art.
It's like giving artists a set of intelligent brushes, instruments, or writing tools
Yeah.
that can amplify their creativity and help them bring their visions to life.
Right.
But wouldn't that raise concerns about AI replacing human creativity?
I think it's more about collaboration than replacement.
Okay.
These AI tools would act as creative partners,
Hmm.
helping artists overcome creative blocks,
Right.
experiment with new techniques,
Yeah.
and explore uncharted artistic territories.
So it's not about replacing the artist, but expanding the artist's toolkit, providing new avenues for expression and exploration.
Exactly. And this brings us back to that idea of augmentation. It's about
Mhm.
using AI to enhance human capabilities, not to diminish them.
It's a really powerful concept, and it seems like LLM AutoDiff is pushing us closer to a future where this type of collaboration between humans and AI becomes the norm. But let's not get too carried away with these grand visions of the future. How might LLM AutoDiff impact our everyday lives in more practical ways?
Well, think about all the tasks we do on a daily basis that involve language and information processing.
Okay.
Writing emails, scheduling meetings, researching topics, summarizing documents, even just trying to make sense of the constant influx of news and information.
Right.
LLM-powered tools could significantly streamline and enhance all of these activities.
It's like having a super efficient personal assistant who can not only handle the mundane,
Yeah.
but also help us be more productive and informed. Imagine an AI assistant that can help you write a compelling presentation research, a complex topic for a project, or even draft a personalized letter to a friend.
Exactly. And with LLM AutoDiff working behind the scenes to continuously optimize these tools,
Right.
they would become more powerful, intuitive, and personalized over time.
It's an exciting vision of the future, and it seems like LLM AutoDiff is playing a key role in making this vision a reality. But before we wrap up, I think it's important to acknowledge that any powerful technology comes with potential downsides.
Mhm.
Are there any risks or challenges that we need to be mindful of as we embrace this AI-powered future?
Absolutely. One potential challenge is ensuring that these powerful AI tools are used responsibly and ethically.
Right.
We need to be mindful of issues like data privacy, algorithmic bias,
Yeah.
and the potential for misuse.
Yeah.
It's crucial that we develop safeguards and regulations to ensure that these technologies are used for good
Right.
and don't inadvertently perpetuate existing inequalities or create new ones.
It's not enough to just develop the technology. We need to consider the social and ethical implications as well.
Yeah.
It's about shaping a future where AI empowers us, not controls us.
And that's ultimately what makes this such an exciting time to be alive.
Yeah.
We're on the cusp of this technological revolution that has the potential to transform our world in profound ways.
Right.
But the future is not predetermined.
Yeah.
It's up to us to shape it, to guide it, and to ensure that these powerful new technologies are used to create a better world for everyone.
I think that's a great note to end on. Thank you so much for joining us on this deep dive into the fascinating world of LM AutoDiff. It's been a real pleasure exploring this with you.
Yeah, thanks for having me.